So today we're going to run an aldol condensation, and we're going to run that between K2, ketone number 2, which looks like it's a solid in there, and B4, benzaldehyde number 4, which we can't really see what the color is, but we'll see. And it's got sodium hydroxide out. And I also have out my 10% hydrochloric acid for quenching that at the end, and the ethanol, because we're going to need to make some 95% ethanol for washing it. I'm going to grab a couple of graduated cylinders. Probably need those. And a glass stirring rod for stirring. Always good to have a micro spatula handy. We're going to do that reaction not in a test tube, but in one of these 10 milliliter Erlenmeyer flasks, because it'll be much easier to stir in a 10 milliliter Erlenmeyer than it would be in the test tube. And we'll get out a stirring hot plate, because we're going to need that at some point for heating the ethanol. So we'll have that at the ready. And we'll have a beaker where you can put that ethanol in there. And this will allow me to stir it so that it doesn't bump. I'll have that all set. And I'm going to need an ice bath at some point. So I may as well go and get some ice and let it start melting so we can have a nice ice water bath when the time comes that we need it. So we'll just sit that in the back of the hood until we need it. The ethanol will go over here because we're going to make up some 95% ethanol. Grab the DI water. Always need pipettes. I'll grab a couple of pipettes. Get those set. Some Erlenmeyer flasks to set them in. And then I'm also going to pull a third pipette that I'll use to measure my benzaldehyde, since that one's a liquid. Oops. So we'll start by taking our Erlenmeyer flask, and I'm going to put that on top of a 100 ml beaker to make it easier to drip my benzaldehyde in. So we'll take our aldehyde and our ketone over to the balance. Since one is a solid and one is a liquid, I'm going to add the liquid first, and then I'll measure the solid out on a piece of weighing paper. The purpose of that beaker is just to allow me to get my pipette closer to the flask. So we'll tear that. Just crease up a piece of this paper ready. And we are mixing 0.20 grams of the ketone with 0.25 grams of the aldehyde. So we'll start by opening this. And just carefully dripping in aldehyde. And you can see if you hold that against the whites that that's a pale yellow, very pale yellow liquid. Probably would be colorless if it was pure. So we're just going to drip that in. I was counting the drops, and I added about 18 drops, and just as luck would have it, 18 drops is exactly 0.250 grams. So that is quite a coincidence, but I'll take it. Now we're going to measure our ketone. And this one I'll measure out onto a piece of weighing paper. I want 0.20 grams. You see it's a white solid. Maybe a little color to it. Like the aldehyde, this one is almost certainly colorless when pure. That's 0.202 grams. That's close enough. So we can put these two back in the cabinet. We don't need them anymore. And I'm just going to add this to the Erlenmeyer flask right here on the bench top, so I don't spill anything trying to carry it back to the hood. And I wasn't upset with having a little extra, because there's always going to be a little bit behind on the weighing paper. So while I'm here, I'm going to crease another piece of weighing paper and tear it, because the next thing I'm going to want to do is to measure out 0.050 or 50 milligrams of sodium hydroxide. We'll take all this back. I'm leaving that pipette there in case something goes wrong and I have to repeat the experiment. I'll have a pipette already prepared. Use the same spatula, just wipe it off. Can use it to measure out our sodium hydroxide. I'm going to open this over a garbage can just in case sodium hydroxide comes flaking out, which it often does. Try not to get that all over the bench or my hands. So we'll tear that. And 50 milligrams of sodium hydroxide. Looks like I've got 66 milligrams right now. So put a little back in. Kind of chunky. Back in the cabinet. It looks like we're at 0.054 grams. That's just a little more than the reaction called for, but it's perfectly fine. So before I add that, I'm just going to reach in here with my glass stirring rod and kind of break up that chunk of the ketone. Try to get the ketone and the aldehyde mixed pretty thoroughly. And you can see that if I put that on a white piece of paper, it's a kind of a pale yellow and has gone into solution. And I'm just going to add the sodium hydroxide all at once. And then we'll stir that for 15 minutes. And it's looking like it's 20 to 4 right now. So I'll be stirring this until 5 minutes till 4. Get that into a nice cone so it goes in. And again, I wasn't too worried about having a slight excess of the sodium hydroxide because it's inevitable that a little bit always sticks to the weighing paper, although not too much in this case. So now we're just going to stir that. I really should be wearing gloves because sodium hydroxide is not a nice substance to get on my hands, but if I were wearing gloves, since the nitrile gloves are black, you wouldn't really be able to see the color. So we're looking at kind of a yellow solution at the moment. The sodium hydroxide is not quite dissolved. So I'm stirring that around and doing my best to get the sodium hydroxide in good contact. So we're running this reaction without solvent, which is great from a perspective of waste, and not generating waste. But it's also a little bit of a challenge because you don't have something to dissolve the material in. You just kind of have to hope that it's soluble in one reagent, soluble in the other reagent. So you can see that it already looks like it's going solid. Product of this reaction should be a solid. Kind of a cream colored solid almost. And there's really not much liquid left anymore. So I just want to keep mixing that thoroughly, trying to scrape it off the sides of the spatula or the stirring rod. You know, I'm just twisting that stirring rod back and forth to kind of take the stuff that's stuck to it and reattach it to the walls of the Erlenmeyer. See, it's kind of almost a cream color now. The yellow color has mostly gone away, maybe even a faint pinkish tone. So the reaction is obviously going because we did have a yellow liquid. We don't have a yellow liquid anymore. And that's only been stirring for about 2 minutes. And the reaction may be done. It seems to have been a very rapid reaction. It's on such a small scale that it really hasn't generated very much heat. The Erlenmeyer flask in my hand is still comfortably at room temperature. It's almost a complete solid mass now. So I'm just trying to kind of scrape the solid down the walls. So we get good contact, good mixing. It's even fairly powdery now. You can, if I mix that around, you can kind of see it. Almost all trace of liquid is gone. Some solid sticking. We lost a little bit right there. Stick sticking to the stirring rod. I'm trying to scrape as much as I can off the stirring rod and then force it down into the bottom of the flask, losing little bits around the edge. And stirring for 5 minutes. Nice looking solid. See, if I hold it that way, you can see there's some free-flowing solid in there, in addition to the stuff that's stuck around the walls. A lot more free-flowing solid now as I'm pulling that off the bottom of the flask.